All right, so I am going to be going over the Desmos project description, and I'm also going to go over a couple of basic functions in Desmos. So this is Miss Rogers. For my class, you'll go to the unit page and go down and choose your artwork first. For Mr. Rogers and Mr. Millers or any other teachers, you may or may not have to do this step, but for my classes, I want you to complete the choosing your artwork box first. So that means you need to, if you're working with a partner, identify who that partner is, and then choose your artwork. So say you want to do Lilo and Stitch or just Stitch. Need to make sure I can spell Stitch. So say you want to do Stitch. Stitch is a pretty challenging one. He's got a lot of details. But if you want to do Stitch, this is a really cute Stitch. I'm going to save the image of Stitch that I want to do. I'll just save it to my downloads and then go back, and when you submit to this project assignment, choosing your artwork, you'll submit the Stitch. And when you do that, also, if you're working with a project, please note who your project is. I need both project partners to complete this step. I want to know that you have confirmed, you both confirmed that you are choosing to work together. Apologies for any noise. Then you're going to head to the Desmos graphing project. Now, your teachers on different Canvas sites may have set up the access differently, but for my classes, you can just click the next button, and you'll find our project description, a couple helpful links, and you'll also find the link to this video once it's posted here. All right, so here are a couple examples. I want to quickly note our rubric and how we'll be grading this. You need a minimum of 50 functions. Your target image and your Desmos art need to show a strong resemblance, and they need to show continuity. It shouldn't look like pieces and parts. It should be gorgeous. I want to print it out and put it up in my room. So use multiple colors to create a vivid piece of artwork, colors that are appropriate to the picture. And then here's the meat, is the variety of equations. So you need to use a variety of equations. In the project description above, you can see all of those types, the numbers of each types. And if you're missing functions, you'll see how many points will be deducted based on how many points are missing, okay? Also, if you work with a partner, there are 5 points built in there for collaboration. If you guys are having issues with collaboration, you can lose these points. So please make sure you are working well with your partner. If you work with a partner, it may cause less work, but it means you need to be prepared to navigate teamwork. If you are not working with a partner, you can get these 5 points free. So up to you to decide which way you want to handle that. Let's get on to getting started with the project. So say I want to do Stitch. I've downloaded the image of Stitch, and I'm going to go to desmos.com. Now, the way you want to start this is you're going to add a picture. So I'm going to go to Add Item and add an image down here. I'm going to pick my download from earlier. Here's my Stitch picture. Now, when I select this picture in my list, then it brings up some points. I can move the picture around, resize it. Some images come in really small. It's sometimes nice to make them bigger so you're not working with tiny, tiny decimals. I do recommend you move the picture around because one of your requirements is a polar function, and polar functions can only be centered at the origin. So say I want to do his little eyeball here with a circle. So when I zoom in, I need to move his eyeball until it is right at the place I want to be able to do a polar function with a circle. And here's the benefit to getting a really good quality photo. Play around with a couple different photos before you lock it in and turn it in. See how well they zoom and crop in Desmos. Make sure you download it. You can also play with the opacity. This is opacity 1. I can make it A and add a slider, and then play with making it lighter or darker, or make it go away entirely. There's something you can play with. But if I do a polar function, it must be in terms of r and theta for it to interpret it as polar. So I'm going to say r equals cosine of theta. And there's a circle to the right, but it's more than double how big I want my circle to be. So maybe I'll say this is 0.5. Oh, that's awesome. So I'll use that for his eye. But his eye is white, so I'm going to use a a different color, I could use black here and leave white in the middle. And that's what I'm probably going to do for this one. But if I wanted to do some other part of Stitch and outline maybe his ears in pink and his head in blue, I might use what's called custom colors using RGB values. So if I want a custom color, it has to be a C equals, and you're probably going to need more than one color. So I like C1, C2, etc. And you're going to set that equal to RGB parentheses. Now, RGB values by definition have three numbers, a red number, a green number, and a blue number. You can actually go to the internet and search RGB values for your character. So if I say RGB values for Stitch, Stitch color palette, here's my color palette. So RGB 78, 188, and 255. I'm going to copy that and paste that in my RGB. And when you get this color box, that says you've added a color. So maybe I make his eye, this is probably not the best one, but once you've added a color, it'll show up in your color options and you can change it to that color. The last thing to consider when you are working on this project, especially if you are working with a partner, is how to save. One, you're going to need to log in. So really quickly, I'm going to sign in with Google so I can associate this with my account. And we're loading, loading, loading. I choose my Wake County account. And so now I can click Save. And I'll say Stitch Example Graph. And now it's saved. Now, if I want to access it again, I can go to Desmos and it'll show up in my saved graphs. However, if I open it up, and then I make changes. Say I add another function, y equals x squared, and I reflect it. I started working on that blue section of his eye, so I shift it right up a little bit. Maybe I need to shift it up 1.5 and right maybe 1. Oh, that's a little far, maybe 1/2. You can play with these values, maybe restrict it. Oh, one way you can restrict things, I brought that back by clicking Control-Z. You can also use the undo button up here. But if you want to restrict it, say the left half of this actually works pretty well for the top of that, but I only want the left half of this. You can use these brackets. They should be on your keyboard near the P button. And then Desmos only uses inequalities. So I'll say I want from negative 1 to is less than x is less than 1. See how much that gets me? A little more than I want. One thing you can do is make a slider for B and then C, letters you haven't used before, and say make sliders for all. And make C, always make B less than C. And so I'll increase B until, hey, I want it somewhere in there. That's 0.8 and 0.5. So let's make it negative 0.65, maybe 0.7. That's pretty good. And then I'll play with C until it's where I want it to be. That's pretty good. Okay, I might need to stretch and compress this a bit. 1/2, oop, nope, let's maybe do 2. That's a little dramatic, so maybe 4/3. Play with, 4/3 fit really nice, right? So play with different restrictions to get it to a nice point. And then I usually replace the C and then I can close the sliders so you don't have a billion sliders. One other thing that's really helpful is folders to organize. Some people choose to organize, say you keep all the function for the ears in this folder. Some people like to organize based on required functions, so all the exponentials in one folder. You're going to end up having lots and lots of lines, at least 50, probably more. So using folders can be a really nice way to collapse a bunch of big sections and make your way through. You can also use the note to add a note about all functions must be appropriately restricted or something like that. So you can use the note function to leave messages. But back to saving, now that I've made changes, if I click save, now in my list it's updated. However, and if I click stitch example graph and I say open graph, it has all the changes I made, right? But if you want to share it with your partner and you click copy link and you send them that link and then you make changes, so maybe I make this just cosine, that's an old version of my cosine, and I paste the old link because I sent it to my partner, that still has the 0.5, right? So the link updates every single time you click save. So every time you click save, you need to share that new link. And if you're working with a partner, I highly recommend you start a Google Doc. And every time one of you clicks save, you post that new link in that Google Doc. And maybe make notes about what changes were made in those links. Also, if you are working with a partner and you are not physically next to each other, it can be difficult to work at the same time and then merge your changes. So please don't get into a pickle where it's the night before and you're having to merge a bunch of changes. If you work separately, it's also really important that you have the same center, same dimensions of the picture, because if you work with two different sizes of stitch and then all your functions are oriented towards two different sizes of pictures, your work will be impossible to combine. So please don't get yourself into that pickle. It can be really, really annoying to fix and very time consuming. You essentially have to do all of your work over again. So that is all for the Desmos project, a couple of crash courses on some important skills. If you have any questions, please reach out to your teacher. And if you have any questions about things in this video, please reach out to Ms. Rogers.